Alright, welcome back guys. Today we have a house AC unit where the evap fan is not running at all.
And this is now our #1 project.
Number one project because it is getting hot.
Yes.
Let's see what we can come up with. Alright, let's go out there and take a look at this here blower. Alright, we're under the house. Fortunately, we can stand up under the house and it's not like up in the attic or anything like that, or we gotta be crawling on our belly.
Thank you, God.
Up under the house. And the first thing I'm gonna do is I'm gonna just disconnect. I'm gonna disconnect, pull this disconnect out, okay? This is 240 volts going in here to this unit. Now I've already removed this here cover, 6 sheet metal screws, you know, and that'll come right off. Now here's our fan that is not running. As you can see, we have quite a few wires here on this thing.
Pick a color, any color.
Any color you want. Where's the problem? First thing in diagnosis, and everyone can be a great person in diagnosing problems, is when you have a problem, just convince yourself that something is causing it.
Really?
When it's not working. Well, we'll go over these here wires here in a little bit. But basically what we have here is we got 2 connectors, and it's going to be hard to see. So what I'm going to do is I'm going to unplug this connector. This is what they call a communication lines right here. We'll go over that later on. We also have line power, right? We have the line power that's going in here. This is 240 volts, right? It's being powered to this here motor. Now this is a brushless DC motor. This is common pretty much nowadays on all of the evap fan motors, all right? So you're gonna have your 240 volts, that's live all the time. Normally it does not go through no contact or anything like that. Then what happens is you'll have this here line here. You'll be sending 24 volts. AC, which comes off the control transformer, and you have one of these lines that you'll be using for the communication normally. However, manufacturer can program this here as electronic module that's on the end cap that's up here, right? And so my guess is that we're going to probably have some issue up here. So I'm thinking that probably our supply volts and our control volts here to tell this motor what to do, you know, as far as the torque setting. You can look at all of these right here. Think of these as torque settings. So the manufacturer can program any one of these, or he can program multiple of these. For example, if you're on the cooling cycle, you're going to need more speed for the airflow when you're in the cooling mode. So he can program one of these here taps, say for, you know, for a particular torque setting, which will give you a particular fan speed setting for cooling. Now when you go to heat, then you'll be on another tap, okay? Say whichever one that might be. And he can program multiple taps. He can do them all. He can do 2. He can just do 1. And in my case, I only have 1, which is on this purple wire. Now, so I have my 24 volt AC, say it's coming in on this purple wire. Well, I need a common. Well, they put it up here on the line power side. So that's going to be this blue wire. This is going to be our C terminal. Now, the red and the black wire is going to be for the 240 volts AC coming in. Of course, the green is with the yellow stripe is the equipment ground, okay? So what we're going to do...
Now, how do you know all that? How do you know what's what on these colors?
I'm just playing with them in the past.
Oh, okay.
Now, this is called an X13 motor. This is very common. You'll see this X13 used on a lot of these indoor units. Doesn't matter if it's a Goodman, like this here manufacturer, this unit is Goodman. Could be a Train, could be a Carrier, could be a Ream. You're pretty much going to see this across the board. All right. This particular one right here is a 1/2 horsepower, so a 2.5 amp motor. All right. So what we're going to do now is we're going to go back and we're going to plug this back in. This disconnect, okay? So let me just stick him on in there. All right. Now, that put the 240 volts. Here's my line power coming in. There's the 240 volts. You see it's going up there to the power distribution terminal box there. You can see it's on this black and that red wire. Here's a control fuse. That's for the 24 volt AC. You see there's a step down transformer right in here. 240 volts on the primary, 24 volts on the secondary. That's over on that side. Of course, you can see that we got our heater strips over here. Okay, up here we have a control relay. So basically when we go back up and we're going to turn the thermostat, we're going to turn on the fan so we can get this thing to, you know, put our control volts out here, because right now we should have our 240 volts out here now. Okay, so let's go up there, let's turn on the thermostat, let's come back down, let's check some volts, let's see what we got. Alright, now here's our thermostat. Now right now I have it in the off position. Now this over here, of course, is for the fan. Right now it's in an auto position. So what I'm going to do is I'm going to put it over in the on position. This will make the fan run manually, but it will not start up the compressor or the condensing fan. Because if I was to go over to the auto and I had all this thing plugged up and the fan is not running, then the evaporator coil is going to ice over. Now, let's go back down. Let's do some voltage checks. Alright, so now all of our stuff should be hot down here going to the motor. Now unplug these connectors because it's very difficult to even try to back probe these things. And you could do it over here on the terminal strip that they have over here, but just to play it safe, we're going to go right to the connector itself. Now the first thing I'm going to check is the 240 volts should be live all the time. Now that is going to be coming in on the red wire and the black wire. There's our 240 volts. The green is equipment ground. Now as you know, the green goes back to the service panel and it is bonded with the neutral. So I should get 240 volts between these two wires, and of course I should get 120 volts between this hot and this here ground, which goes back to neutral, and then this ground and then this black I should also get 240 volts. So let's check that first. Alright, so we got 243 volts there, okay? Now I'm going to go between the red and the ground, and of course I should get my 120 volts, 122. Now if I go between the ground and the black, I should get the same 122 volts, okay? So our line power is there. Now for the communication, they take the 24 volts AC, right? In my case, I only have one tap that's being used. Remember, the manufacturer can program this electronic control board up here for multiple taps, depending on if it's got cooling cycle, the heat cycle, single stage, dual stage. So he can program all of these taps if they want to. But in my case, I only have one. And the one that's being used is this purple wire. So between this purple wire, there's my 24 volt AC, and the other side, they put it over on the line power plug, which is going to be this blue wire. So I'm going to check between the blue wire, and I'm going to check between the purple wire. And we should have 24 volts AC. If I can make a good connection. So you can see that I got 27 volts AC. So everything looks fine here. So that now means we need to pull this here blower out.
Oh.
Yeah. Okay, so let's do that. Now fortunately, it's not that big a deal to get this here blower housing out. As you can see, it's mounted on a track with the inside of runners here. Now there's two sheet metal screws that holds this thing in using a 5/16 nut driver. So there's one, and we got one up here. Okay. And now let me go ahead and I'm just going to go, before I forget it, I'm just going to go ahead and I'm going to disconnect this here out. Okay. Now, we take this here, we slide it out, and we'll just set them down right there because we have this equipment ground that we need to get off. pull them out just a little bit where we can get to the screw. And again, this is 5/16. And let me just screw him right back down in there. Okay. All right, let's go inside the house. Let's take a closer look at this thing. As you can see, typical of all these indoor fan motors, it's a squirrel cage. Turns freely. Okay. Now what we're going to do is we're going to pull the end cap off of this motor. Now, as I mentioned before, you can see this is an X13 motor. It's a half horse, okay, and it's made by Gentech. Now, this manufacturer right here pretty much makes all of these units, these X13 motors. Okay, so there's a 1/4 inch nut driver, fit the bolts. It's 2 bolts.
That says 2010.
Yep.
We weren't even...
This unit was installed in 2011. Okay. Now, all you have to do, and you guys see all of the, you can see the 2 connectors here. All the line power is down here on the bottom. And we'll pull it off. You can see that we'll see this a little bit better. So it just pulls out. You're going to have this here connector. Comes from this electronic board, and it goes down to the stator windings here. Okay, so you unplug it. Okay, it's keyed, so you can't put it in backwards anyway. And this is the unit that is controlling this motor. Okay. Now, if you look down here in the motor, this here motor, it's just like this. You can think of this like a 3-phase motor. Okay. You have the stator windings around here, okay? If you look at the rotor, it's a 4-pole rotor. It's got 4 magnets on it. Each one of the poles here are alternating, north and south poles. And what basically happens, it works just like kind of like an AC motor, except it's using DC pulses out here, 3 phases of them, 3 of them. And what it's doing is it's making electromagnets out of these here coils. And it's going to be alternating, it's going to be going around, so this magnetic field is rotating around, and the electronic board is doing that, and it's making north and south poles. Then that's going to interact with the rotor, which has the permanent magnets on it, and then that's going to track one behind it. It's going to be pushing away, and so basically 2 cores are on it, I think, at one time, and it's going to make this here rotor just rotates. Now the speed is controlled by, of course, how fast the magnetic field is rotating around the stator, so they can control that. Now, think of this motor as a 3-phase motor. It's going to get 3 signals here, 3 output signals from this here controller board. Okay. Now, the windings, treat them just like a 3-phase motor. If you check between any 2 of the windings, you should get less than 20 ohms. All right. Now, whatever reading you get, less than 20 ohms, they should match up between all three phases. Okay, so let's check that. I'll give you a demo here. So remember, we are looking for less than 20 ohms. Okay, you see right there? We're going to call that, we'll call that 13. Yeah. 13 ohms. Okay. All right, so this is where I'm at right now. Now I'm just going to move my lead over, okay? I should still get the same reading. Should be plus or minus 10%. Okay? Yep. And I'm going to call that good. 13 ohms. Now I'm going to take this lead and I'm going to move it over here. That's all 3 possible checks on looking at all the windings here. So there you go. That's 13 ohms. All right? That looks good. All right? Remember, you want your readings to be plus or minus 10% of each other. The other thing you want to check to see if the windings are grounded. All right, so put your lead there on one of the windings and check to a good frame on the grounding here. What we're checking for, we want to make sure that these windings are not grounded. Okay, That looks good. OL, you can't get no better than that. So it shows no leakage resistance from the winding to the frame. Anything over 100,000 ohms, you can look at that as being good, but the higher, the better, okay? If you got something that's under 100,000, then the motor's going to be bad, all right? So then, move it over to your next winding, do the same thing, okay? Again, that's good. Again, move it over to your last winding, go to ground, and you see that one's good. All right, now obvious. Now the motors do go bad, you know. You could have stator windings. They can, you know, short out. You can open. If you see anything that's open or shorted from what we just showed, motor's bad. Also, like I said, we spent it before, right? You got any bad bearings? Bearings are in here. This one all seems pretty good, okay? So that looks good. Now going back to this, we'll talk about this a little bit. If you look up here, you can see that it's marked. You got your line power, you got a G for ground, you got N, which is neutral. Now, some of these motors actually can come at 120 volts. So of course your line power is going to be between the N and the L. If it's 240 volts, like in my case, then it's going to be L and it's going to be N that's going to be used for the 2 hot wires. Of course the G is equipment ground, and if you look right over here, you can see C, which is common. Common is going to be for the communication line. That's one side of the 24 volt AC. You're going to use that in no matter what case for your communication taps. Now your taps can be 1, 2, 3, 4, or 5. Now the manufacturer, he can program 1, 2, he can program them all depending on what the needs are that he wants this here unit to do. As I mentioned, it could be heat, it could be cool. In my case, I think the manufacturer just picked a happy medium between the cool and the heat. Maybe put a torque rating, you know, right there in the middle. And so I'm programmed on number 4, which is the purple wire. Okay. So when you buy these units, you can't get a generic replacement because there is no standard in the manufacturer that, okay, this, if it's say single stage for heat, they're going to be on number 1. The manufacturer is left up to them. They can program any terminal they want for whatever torque setting they want. Now, a lot of times people will say these are speed taps, but they're constant torque. This is a constant torque motor. So the variations between these taps will give you various torque readings, or torque settings rather, and then that will actually vary the speed too. So when you buy one of these things, you will have to get it from the manufacturer to be sure that you are getting the correct unit which is programmed for your unit. Now, how do you know which tap's being used? Well, you have to look at your service literature or your owner's manual for the air handling unit, and it should tell you in there. But for the most part, you have to go directly back to the manufacturer. The only problem is going back to the manufacturer, a lot of times they're not going to sell it to an individual. Okay, so that means you're going to be getting a HVAC tech guy out, right? And most of the time what they're going to do is they're not going to separate this unit out and say, okay, your unit here is bad, or no, your motor is bad. They're going to replace the whole entire thing. Now, depending on how the tech feels that day, your price for this is going to vary from $1,200 to $2,000. So
For this one piece?
Well, what they're going to do is they're going to replace the whole entire unit.
Oh, gotcha.
So you're looking at $1,200 to $2,000. And I did not want to try to go that route, at least not to start with. So what we're going to do is we're going to see if we can do something here. But anyway, let's do some more checks. Most of the time, 95% of the time, this is going to be your problem right here. Now, I did a little checks on the forums, HVAC forums, and some of these things will last 2 years, 3 years, 5, 6 years. In my case, 7 years. But they're pretty much destined to fail for whatever reason. Okay. You can see they got a choke in here just to limit the current on the start up of the motor. Not sure what this is. I think they're using MOSFETs, you know, to switch the outputs. Usually
MOSFETs.
MOSFETs, metal oxide semiconductor field effect transistor.
Well, aren't you a smarty pants?
Or they could use IG BJTs, basically any kind of transistor. That's the insulated gate bipolar junction transistor. Or could use BJTs.
Okay, now you're just showing off.
Now I'm just showing off. We have output filter capacitors. They're 1000 microfarad at 200 volts, right? A lot of times you can look at your capacitor. If you see the top up here is kind of swollen up, it's like a little dome, then you know that the capacitor is bad. In my case, you see they'll look pretty flat.
Yeah.
Okay. The biggest thing with these is you can see that they pour this rubber potting material in here, so you can't really get access to the components to even check this stuff, right? Now, one thing that you can check, and it is common, happens a lot, is that this component right here. Now this component is a thermistor. Has a resistance of 1 ohm, plus or minus 20%, has a 20 amp rating. It's made by Amatherm. You can see there's a part number on it, SL22 1R020. You can check, put your ohm meter leads on here. You can see that it should be 1 ohm, okay? And now if you see that it's open, crack, or a lot of times these things are actually cracked and you see it's obvious that it's broke. That will prevent the motor from running. So let's do a check on that. We'll see how that looks. All right, so I got my ohm meter here, and I'm going to check the resistance of this here thermistor. This thermistor is the NTC type, means as the temperature goes up, the resistance goes down. All right, and this is actually it's used for a current limiter for the motor. We'll start up. Now, if this joker is open, okay, see, I'm not lucky.
1.4. Yeah.
So we're good. So this thermistor is okay. Now, everything else on here is pretty difficult to test because it's all filled up with this here rubber. I mean, you'll have to dig this crap out of here, and that'd be a job in itself. Okay. Now, with the magic of time elapse, I have another module here. All right. Here's the original, and here's another one. Now, this is not a new module. This is a used module, but according to the guy from eBay, it was bench tested and it works. Okay. Now, you can see that it looks pretty much just the same.
Yeah.
It's an X13 unit, right?
Yep. Yep.
You can see the components are slightly different, but this is a newer model. Probably, they have revisions over the years. This here was manufactured in 2010. This was manufactured in 2016. Okay. Now, let's go about the pros and cons when you buy something that's used. Now, as I mentioned, the manufacturer programs these taps, right? He can program 1, 2, 3, 4, or 5, right? He can program one and all 4 of them are blank. Now, as you remember, I am on terminal 4, right? Of course, and I'm using this, you got to use a C no matter whichever tap you're using, all right? You don't know anything about this right here. See, I don't know what unit this came out of. Now, that means that this here is programmed for some unique torque setting, right?
Right.
And I don't know for sure which one of these taps are being used. Maybe number 4 is blank, okay?
Right.
So, and it may be something on it. And if it is something on it, it's possible that it could be the wrong torque setting, which give me the wrong speed for what the original was. This is one of these things do you want to try spending $100 like I did on this one for eBay and see what you got, hope it'll work, or do you want to spend from $1,200 to $2,000? So I'm going to go try this route first. Okay, what do we got to lose? We don't have AC, so doesn't matter, right?
Thank God for the...
Let's go for the cheap route.
Yeah, right.
All right. So that's where we're at with this unit right now. Okay.
So is it just a matter of swapping them out?
Right.
See if it works.
We just plugged the other one in.
Yeah.
Put the 2 screws in, bolt it in, put the 2 connectors back on, and then see what happens.
Oh my God, wouldn't that be great?
Yeah. Our luck don't normally go that way, does it? Let me tell you about another thing that can happen. All right. Now, the rotation of the motors. Now, you remember now, depending on how the air handling unit is, you know, whether it's horizontal, vertical, you remember how the squirrel cage goes in there, it's possible that the motor might need to go the other way. So, so this being out of another unit, it could be that this motor is totally backwards from what we have, and the rotation is going to be wrong, right? And my understanding of how that works is that the rotation is not programmed into the motor initially. So what happens is the unit will start the motor up, it'll run it in one direction, then it's going to look at the current. If you have airflow, then your current's going to be up, all right? Then it will turn around and it'll reverse the motor, and then with no airflow, of course, then you're going to have very little current. And at this point, somehow, the board will program itself to that rotation, all right? So it's quite possible that when we put this unit in, this motor may run backwards because it was basically programmed to the other one. It programmed itself to the other unit. See what I'm saying?
Which won't help us.
Which ain't going to help us,
So
right?
what do we do then?
So as I said, the motor could run backwards.
Right.
So what we could do on that is, and I don't know for 100% this will work, but I'm going to, the motor itself is like a three-phase motor. So it's 3 leads. So what I'm going to do is I'm going to swap 2 of the leads if the motor runs backwards, and hopefully this motor will run in the other direction. Because remember, this unit is already pretty much programmed. So if I take 2 of the leads on the motor and swap them, hopefully this thing will run the other direction. If it does go in the wrong direction.
Okay.
Alright guys, I got good news and I got bad news. The good news is I went ahead and took the module that I got from eBay. I took it, put it on, I took it out there, hooked it all up, turned it on, the fan motor ran. And I didn't have to change any tap. Now, am I sure about the torque setting of what it was originally? No, I don't know, because I don't know what kind of speed, you know, anything like that. But it did run. The only problem is what I was talking about earlier. It is running backwards. Okay. Now, if you look at this, you pretty much just tell that the fan motor needs to go this way. It picks up the air inside. This is the air intake, right? My evaporator is over here. It's pulling the air from the other side of the evaporator, from the return, pulls it through the evaporator, comes up underneath the fan, goes in here, turns, and now it's going to come out this way, right? And this is going to be our supply, going to our supply duct.
Okay.
Now the only problem is my fan is going that way. So it's very little airflow. In fact, if you was to check and look at your vents, you will see that you actually do have airflow. It will have a little airflow, but it is very, very low, okay? It's enough to cause the evaporator to freeze, okay? So, we're back. Yes. Hey,
And I'm sweating.
I'm still thinking about that
$1,200.
$2,000 damn dollars, so
It's a lot of Outbacks right there.
you know it. So let's pull this freaking thing back apart again. Okay. Remember, this is the one from eBay. It does work, except now the motor is backwards. Okay. Alright. Now, so it's like a Molex connector. Now, I could research and find this, you know, finding a pin extractor, you know, to put down there, pull these out, swap the 2 leads. Like I said, treat this like a 3-phase motor. If you swap any 2 of these leads, my hope is that this here motor will go in the other direction. I do not know that 100%, but I'm going to try it. So in my case, what I'm going to do, since I don't have the extractor, is I'm just going to cut 2 of these leads. It doesn't matter which lead you cut, any 2 of them, that should reverse the motor. I think what I'm going to do, I'll probably do the red and the blue lead. So I'm going to cut it, snip it, swap it, solder it back, heat shrink it, and then we're going to give it another try.
Nabbit.
Yeah. It just keeps snowballing, don't it?
Yeah.
All right. Let's see. Maybe right there, and maybe right there. Okay.
Strip them. Oh, nice.
Okay. And then we'll strip these two down here. Let me lay this thing on the side so we don't get the insulation down inside the motor. Get up here. Okay, that's good. Okay. Put some rosin soldering flux on the end of the wires. Just kind of dabbing them down in there. Okay. Putting a heat shrink on there. Okay. Trying to get my hand steady. Hold it still now. Okay.
Burn, baby, burn.
Come on. You're gonna hold that connector from bobbling around. Just hold it still.
Good?
Yep, looks all right to me.
Watch it.
Looks good to me.
Mm-hmm.
All right, this is gonna be the moment of truth here.
Let's hope this is it. I'd love some AC.
Okay. Now. Put our little bolts back in. Is it gonna work, guys?
Let's hope.
Come on, guys, y'all. Don't be so pessimistic.
What do you always say? A realist, not a pessimist?
I'm a realist.
I'm an optimist.
You're an
It's going to
optimist.
work, guys. We're going to
Yeah.
get down to 72 degrees when we get this thing going.
I hope. All right, let's take this thing down and let's go ahead and we'll put it in. We'll see what happens. Okay. All right, first thing we're going to do is going to put this here ground screw back on.
All I can say is if we had to lay down in this basement, you'd be doing this with someone else.
Now we'll slide it back in the track.
Nice.
And then we'll put our screws back in. Get it there.
Let's hope so. Last time you have to take those screws off, right?
I hope so.
For another 7 years.
I hope so. Okay. All right. I'm going to go upstairs and I'm going to turn that fan switch back to auto before I plug all this back up. Okay. And of course, right now I have the disconnect out. All right. All right. I'm going to plug up the line power. It goes on the bottom. You can't plug these in wrong. Right here, you see it's a dummy plug, so it only go in one way. So I'm going to plug him up. And then this one here will go up like that, where this here prong will go up. You can't flip it up because then it will interfere with the other connector that's on the bottom that we just plugged up.
Okay, good.
All right. Now,
The magic last one.
now let's put our disconnect back in. Okay. All right. All right. All right, Saraya.
The moment of truth.
Yeah, what I want you to do is go back upstairs.
Okay.
And on the thermostat, you remember on the fan switch?
Yes.
Remember it had auto and on?
Yes.
So I want you to flip it to the on position.
Okay.
Okay? And then I'll watch it down under here.
Okay.
And then I'll see this thing when it starts. And then this way I can see if the rotation is correct.
Okay.
Alright guys, we're over a vent. I got a piece of paper towel here. Look at that, look at that.
Woo!
Isn't that beautiful?
I'm gonna close windows.
Josie, doesn't that look delicious? Woo! Okay, I think we're ready to turn this thing on. Let's put that cover back on, and guys, and then we'll fire this thing up on the AC and see what we got. Wasn't that great, guys?
Yes.
Save ourselves what? Thousands of dollars, a couple of thousand probably. We're gonna put this here cover back on. It's got a lip over here. Slide that in over here first. Okay. Now slide this one back over here.
Just 2 screws? No.
Yeah.
More than that. 4, 6. 6 screws.
Yep. 6 screws.
So you got 1, 2, 3, 4, 5, 6, and we're done, right?
Yep. Just some sheet metal screws. All right, guys. Once I get these screws tightened up here, the next step is we're going to turn this AC unit on, and we're going to see what this thing will do. Okay.
All right.
Almost there. Now, you just saw that the motor was going in the direction that we needed, and you saw what we did to accomplish this, to make this motor go the other way. And I guarantee you, you're probably not going to find anything out there on YouTube or any other source. Okay, so it looks like a 1/4 inch. Nope, it's 5/16. I tell you what, I was happy as hell that we were able to, you know, fix this thing. And hopefully, guys, this might help you guys out there, because like I said, this unit, this here X13 motor, that joker is in everything, okay? In all these units out there. Doesn't matter pretty much who the manufacturer is, as I mentioned earlier up on in the video.
Well, what's this for here?
This is where you can put in a circuit breaker, you know, like a disconnect is an option. See right here, circuit breaker is not intended for branch circuit, but in this case, there is nothing there. So the disconnect is up here above.
Oh, okay.
Yeah, just one of those options if you know, I guess we don't know if the manufacturer is going to put it in there.
Okay.
But he didn't.
All right, let's go get cool.
All right, let's try it out. All right, right now it's 78. Let's put it on cool. Let's put it on 72.
Yes. You mean we'll get to sleep out on bed tonight?
Yeah. Fortunately, guys, we have another unit. We have a bonus room upstairs, so it has its own separate unit, so it's not like we were suffocating here.
I hear it.
Okay, 72. Heard the fan come on.
And it sounds powerful now.
Yeah. All right, let's go and let's check the AC, see how it's doing. Okay, we still got good airflow. That looks good. Let's go check the compressor. Let's check the condensing fan. Let's make sure it's running. Okay, compressor's running, condensing fan is running, and the evap fan is running. So we're gonna give it a little bit, and we'll let it run an hour or so. We'll check the temperature, make sure everything still looks fine, and then we'll close this video out after that. All right, guys, you can see that we started at 78. We're down now to 75, and it's still coming down. It's probably been running about an hour and a half, and so it's a lot of space in here, you know, to bring the tip down. Let's go ahead and wrap up this video. Okay, so you see that if you do have a problem like that with your evap fan motor, hopefully you got the steps now, you can troubleshoot it. And also, if your motor does run backwards, you do now know that you can reverse any two of those wires going down to the stator windings, and that will make the motor run in the reverse direction. So, hopefully you find the video helpful. I appreciate you guys watching, because this is a long one, but I wanted to leave all the steps in there so you can see exactly,
Thank you.
what happened here. It's hopefully to help you guys out if you do want to tackle this job yourself, and in the process save yourself some money.
Okay, now tell them about the goosebumps, baby.
Oh yeah, actually I ain't lying. Come over
Me
here and look
too.
at,
Me too. Can we see
really,
the goosebumps?
I'm serious. Can you see? I don't know if you can see that, but can you see the goosebumps I got?
I can see them.
I mean, it's starting to get a little friggin' cold in here
I
now,
like it, baby. I like it.
which is a good thing.
Yep.
All right, guys. You guys take care. We'll see you in the next one.